Let's address the common globe of math and why each one uses circular reasoning or unfalsifiable assumptions. Behind me, I have the circumference formula. It assumes Earth is a sphere in the formula meant to prove it's a sphere. That's circular reasoning, using the conclusion as a premise. The r, radius, only exists if you've already assumed a sphere. This is unfalsifiable. Then we have the gravity equation. It describes the observed phenomenon, things fall, but doesn't explain the mechanism. Newton himself said, hypothesis non fingo, meaning I don't feign hypotheses about the cause. You're describing observations with math, not proving what causes them. Electromagnetic density gradient plus buoyancy explains the same observations without requiring an invisible attractive force pulling through the vacuum. Plus, gravity has never been isolated and tested. And then we have distance to the horizon. Assumes radius, the radius of a sphere. Uses spherical Earth in the formula meant to prove spherical Earth. Also assumes disappearing ships are due to curvature rather than perspective convergence and angular resolution limits, which zoom lenses disprove by bringing those disappeared ships back into full view. In orbital mechanics, Kepler's laws. Math working doesn't prove which model is true. The Ptolemaic geocentric model made accurate predictions for over 1,500 years using epicycles. Heliocentric and geocentric both have math that works. Math fitting observations doesn't prove the mechanism behind them. And Eratosthenes shadow angle calculation assumes the sun is 93 million miles away with parallel rays. But if the sun is local, meaning closer, the exact same shadow angles result from divergent rays on a flat surface. You can't use the calculation to prove the distance without already assuming the distance. That's circular reasoning. Foucault Pendulum demonstrates an effect, apparent deflection in a rotating reference frame, but this only proves rotation of the reference frame, not that Earth is a sphere. It doesn't prove spherical geometry, and there could be other causes. We need to rule out all alternatives instead of assuming one conclusion and using confirmation bias to interpret the observation. A big one is stellar parallax measurements over time. Tiny measurements, milliarc seconds, that require the assumption that Earth orbits a sun. If you assume the heliocentric model, you attribute observed position shifts to parallax. If you assume geocentric, those same shifts are attributed to stellar proper motion. The observation doesn't prove the interpretation. Ancient constellations are unchanged over millennia, despite a trillion-mile wide baseline. Or trillions, in some cases, which suggests no significant parallax exists. This is impossible if we've traveled 45 trillion miles in the past 4,000 years with stars at vastly different distances. Yet, we still have the exact same constellations. That's impossible in the heliocentric model unless the stars somehow have the perfect speed to maintain their orientation and geometry with other stars to maintain the zodiacal wheel. I mean, that's insanity. And latitude-based observations. Polaris altitude and angle equals your latitude, but this works just as well on a celestial dome model at uniform distance as it does on a sphere. Polaris sits at the north celestial pole, and its altitude and angle naturally matches your north-south position on a plane. It doesn't require a sphere. And time zone differences. These work perfectly on a flat plane with a local circling sun. That's an apparent sun because it's a projection from the Arctic center. Different illumination times depend on your position relative to the sun's circular path. It's your slice of the pie. It doesn't prove a sphere. And spherical trigonometry for navigation. This is mathematics of spherical triangles, but these are calculations performed on the celestial sphere, the dome. as observed from a flat plane. They're not calculations on Earth's supposedly curved surface, which would make zenith radial instead of vertical, and it's vertical. Navigators calculate positions using stars on the celestial sphere, and GPS uses planar coordinates, x, y, altitude, not spherical. Just look up celestial navigation and look at what they use to do it. They have to put you on a flat plane. That's telling in itself. So when evaluating any equation that someone claims proves the globe, ask yourself, does it assume a sphere in order to prove a sphere? Does it just describe observations that fit multiple models? Does it actually prove a mechanism or just fit data? Does it address observable contradictions like the Polaris zoom problem? If that light is 433 years old from 4.5 trillion years behind me, why can I zoom into Polaris directly above the North Pole in real time? No, stellar coordination impossibility. How do stars from the year 1374, 1591, and 2016 coordinate to mark our seasons in 2026? Or the inverse square law of light violation. Why is Polaris easily visible when it should be invisible at that distance? Or the lack of parallax. Why do constellations remain unchanged despite 45 trillion miles traveled with stars at different distances? Each star's speed would have to be perfectly calibrated based on its distance from us to maintain the never-changing zodiac wheel alignment. And the cosmological constant problem, the vacuum catastrophe, where quantum field theory predictions differ from observations by 10 to the 120th power. Math doesn't prove the globe when the observations falsify the model. You can't say something like, well, that's only possible on a sphere. When you do science, you have to ask yourself, does this support sphere? Or does it falsify sphere? Does it support flat Earth? Or does it falsify flat Earth? You can't say, that only works on a sphere. That's not science at all.